Today we're going to continue with polynomial operations, and we're going to talk about dividing polynomials. But before we get into dividing polynomials, let's just talk about long division in and of itself. So I'm going to do long division for this right here, 1085 divided by 4. So what we're dividing by goes on the outside, right? And what we're dividing goes on the inside. And we check, can 4 go into 1? No. So now we're going to go to the next biggest number. We're going to go to 10. So can 4 go into 10? Yes, 4 goes into 10 2 times. Now we multiply. 4 times 2 is 8, and we write it underneath the 10, and we subtract. So 10 minus 8 is 2, and I bring down the next number, 8. So 4 goes into 28 7 times. So 7 times 4 is 28. We're left with 0. We bring down the 5. So now 4 goes into 5 one time. 1 times 4 is 4. And when we subtract, we left with 1. So the remainder is 1. So 1085 divided by 4 is 271 with a remainder of 1 out of what we divided by, 4. So we're going to be able to do that when we have x's involved. So we're going to divide this using long division. So what we're dividing by goes on the outside. What we're dividing goes on the inside. And if there's any missing terms, right, this is cubed, squared, to the power of 1, nothing, we're good. We're not missing anything. But if we were missing anything, we would include a 0, x squared, 0x, whatever we're missing, just as a placeholder. Okay. So what we're going to do is we're going to take the first term in the thing, and we're going to take the first part of what we're dividing by, and we're going to literally divide them. I'm going to take 9x cubed, and I'm going to divide that by 3x. So 9 over 3 is 3, and x cubed over x is x squared. So 3x squared, I'm going to line up with my x squared term. And now I'm going to multiply 3x plus 1 times 3x squared. I'm going to distribute 3x squared to both things. So 3x squared times 3x is 9x cubed. 3x squared times 1 is plus 3x squared. And now what I need to do is I need to subtract. So 9x cubed minus 9x cubed is gone. 6x squared minus 3x squared is 3x squared. And now I'm going to bring down my next part. And again, I'm going to take the first term and the first term, and I'm going to divide those. 3x squared divided by 3x. So 3 over 3 is 1, and x squared over x is x. So this is just plus 1x. Now I'm going to distribute. X times 3x is 3x squared. X times 1 is x. And once again, we are going to subtract. So 3x squared minus 3x squared is gone. 28x minus 1x is 27x, and we will bring down the plus 9. First term. I'm going to do 27x over 3x. So 27 over 3 is 9, and x over x cancels, so this is just plus 9. 9 times 3x is 27x. 9 times 1 is 9. And we're going to subtract. So 27x minus 27x is gone. 9 minus 9 is gone. We had a remainder of 0. So that means my answer is just the 3x squared plus x plus 9. And if we had a million years, I would go back and check. I would do 3x plus 1 times 3x squared plus x plus 9, and it should give me back my 9x cubed plus 6x squared plus 28x plus 9. So here's one for you to try. You can pause. The answer is posted in the blank notes in Google Classroom. If it doesn't go in evenly and there is a remainder, we're going to write it as what we just had, that was the quotient, right? Plus the remainder over what we originally divided by. So for example, 3, I'm dividing by 4x minus 5, so that 4x minus 5 is going to go on the outside. And the 8x cubed plus 14x squared minus 18x minus 11 will go inside. First term. So 8x cubed over 4x. 8 over 4 is 2. X squared. Got a little carried away with myself. So 2x squared would go there. And now we're going to multiply. 2x squared times 4x is 8x cubed. 2x squared times negative 5 is negative 10x squared. And now we subtract. So this cancels out, and now I'm left with 24x squared, bring down negative 18x. So I'm going to take the 24x squared and divide it by 4x. So 24 over 4 is 6. X squared over x is x. So plus 6x. Now multiply 24x squared minus 30x. And we are going to subtract. So that cancels out, and I'm left with 12x here. Bring down the minus 11. We're going to take that 12x, divide it by the 4x. 12 over 4 is 3. X's cancel. 3 times 4x is 12x. 3 times negative 5 is negative 15. And we will subtract. So here I'm left with a remainder of 4. My answer will be written as what I had, 2x squared plus 6x plus 3 plus the remainder of 4 over what I divided by, which was 4x minus 5. And that is what my answer would look like here. So here's one for you to try. You can pause. The answer is posted in the blank notes on Google Classroom. So synthetic division is actually a shortcut if the polynomial that we're dividing by is in the form x minus k. So that means it cannot have a number in front of the x. It's a single 1x plus or minus some number. And this is the process we're going to go through. We're going to take the coefficients of what I'm dividing. So in this case, it was negative 1 for x cubed, 4 for x squared. There was no x term, so 0, and then 9 for the constant. So those were the coefficients. And if it was x minus 3, if x minus 3 is equal to 0, then x is positive 3. So we're going to plug in a positive 3. It's always going to be the opposite sign of what the factor was. Then we bring down the first term. So this negative 1 comes down and it goes underneath. We've made an L shape. The negative 1 came down. We're going to multiply the outside number, 3 times negative 1, and put the result under the next term. And then we add. And we're going to keep doing that. We're going to multiply them. And then add those, multiply them, add those, and whatever's left is the remainder. And then we're going to start 1 power lower than we had originally. So if I started with x cubed, then my answer is going to start with x squared, then x, then the constant, then the remainder. So that was negative 1x squared plus 1x plus 3 plus the remainder of 18 over what we originally divided by, the x minus 3. So let's actually do one together now. We're going to do 2 together. So if I'm dividing by x minus 2, I'm going to put a positive 2 on the outside. I'm going to make my L. And I'm going to put the coefficients. This was 1x cubed, negative 3x squared, minus 7x, plus 6. So we weren't missing any terms, so there was no 0 placeholders. I'm going to bring down my 1. So now 2 times 1 is 2. Adding together negative 3 and 2 is negative 1. 2 times negative 1 is negative 2. Adding together negative 7, negative 2 is negative 9. 2 times negative 9 is negative 18. Add 6 and negative 18, we get negative 12. So that means this is my x squared, my x, my constant, my remainder. So this would be x squared minus x minus 9 plus negative 12 over what I originally divided by, x minus 2. Let's do another one together. So if I'm dividing by x plus 3, negative 3 is going to go on the outside. I have 2x cubed. I don't have an x squared, so I'm going to put a 0 there. Negative 1 for x, and then minus 7. So remember, bring down to start, and then we multiply. Negative 3 times 2 is negative 6. Add these together to get negative 6. Negative 3 times negative 6 is positive 18. Add these together to get positive 17. Negative 3 times positive 17 is negative 51. Add these together, we get negative 58. So my answer, right, if we're starting at cubed, we're going to go to squared, then x, then the constant, then the remainder. 2x squared minus 6x plus 17 plus the remainder of negative 58 over the x plus 3. It's also possible to just move the negative here. That's fine, as long as our remainder was a number, right? If our remainder had more than one part to it, we would be careful with that. But since our remainders are always going to be single numbers here, we could put the minus there and that would not make any difference. So here's 2 for you to try. You can pause. Answers are posted in the blank notes on Google Classroom. So the remainder theorem says that if a polynomial f of x is divided by something like x minus k, then the remainder is actually equal to the function evaluated at that k value. So what that means for us is we can use synthetic division to evaluate a function as well as evaluating functions to find the remainder of the polynomial division. All right, but it means we can use synthetic division. It's also called synthetic substitution to find out the value at a given x value or a given k value. So for example 5, use the remainder theorem to find the value of f of 3 for the function given. So 3 is what we're plugging in. They didn't say x minus 3, right? They just said f of 3. So 3 is what we're evaluating. 3x cubed, 6x squared, negative 5x is 12. So those are my coefficients. Bring down the 3. So 3 times 3 is 9. 6 plus 9 is 15. 3 times 15 is 45. Negative 5 plus 45 is 40. 3 times 40 is 120. 120 plus 12 is 132. So that means f of 3 equals 132. So there's one here for you to try. You can pause. The answer is posted in the blank notes in Google Classroom. And example 6 says, when we have this polynomial and divided by x plus 2, the remainder is 26. What is the value of k? So I'm going to set this up with my synthetic division, my synthetic substitution. So I'm going to put the, 26 is the remainder. I'm going to put negative 2 on the outside because we're dividing by x plus 2. I'm going to put 1, k, negative 4, and 2 as my coefficients. And I'm going to do all my work, and whatever I get here at the end is equal to 26, because the remainder, whatever I get here, is equal to 26. So this is going to be negative 2, and remember we're adding. K plus negative 2 is k minus 2. Now multiply. Negative 2 times k minus 2 is negative 2k plus 4. When I add these up, negative 4 plus 4 cancels. I'm left with just negative 2k. Negative 2 times negative 2k is positive 4k. Add these up, I get 4k plus 2. So this 4k plus 2 is the remainder of 26. So 4k plus 2 equals 26. 4k equals 24. And k equals 6. So there's one final one for you to try. You can pause or end the lesson here. The answer is posted in the blank notes of Google Classroom. And that was dividing polynomials.